Joshua English, who is a local San Diego fellow. He graduated from the Interior Architecture and Design program at the Academy of Arts in San Francisco. So he calls himself both an artist and a designer, but an artist first and then the designer. And it's really because he finds that, you know, art is a reflection of nature, and a lot of his inspiration comes from nature. It's already beautiful and magnificent and already has so many answers if we know how to look and how to kind of navigate through their realm. And then following from the artist side, the designer, and again, nature's already a great designer, so it's already been inspired by nature. And that's how most of this motif has been created. It's really getting the inspiration from the natural world. And over the past few years, he was introduced into fungi, and more just really being curious about the role of fungi and everything that it has done for our natural world. And you know how I'm guessing for a lot of us, you know, it's kind of like the mushrooms kind of really talk to you, and more you find it more inspiring, and it's like, hey, you want to kind of keep paying attention to me. So that's kind of what happened to him, and started really going from being a satellite interest, just kind of like in the back burner, to being the main interest, which is he's doing it through the architectural realm of mycelium, and really created a new method to use mycelium as a way for architectural design. Which he's going to tell you a lot more about it. He also has skills in data visualization and large system design, as well as architectural and industrial design, which he'll give us a little bit briefly more about that information. And so all of this has created his current work through Works, to establish this focusing on harnessing the self-replenishing wonders of mycelium, which I know some of you know more about, but we're about to go in a lot more depth, and into a way that this mycelium could be a substitute for the deforestation that is occurring at an extremely alarming rate. He's friends with people from Ecovative as well as Microboard, that I'm sure you have heard some about. And but really, this is the fungi that we're going to be able to infiltrate the mycelial network, and not just through the mycophagy, the eating or the observing, but now how to being able to use this design to better help our planet, better help humanity, and of course, help save our natural world. So Joshua, thank you so incredibly much for being here. It's really an honor, especially to have a San Diego local. And we're all excited to listen to your talk.
Oh, great. Thank you for that introduction. I'm really excited to be here. I just moved back to Southern California after 28 years in the Bay Area just last year. So I'm really excited to be back down here and being really close to the ocean again. Yeah, it was a very good introduction, because it is true that all of my inspiration as an artist, as a designer, have always come from the natural world. And as I'm always working on any project, I always try to take that time to connect with nature. It's my way of kind of refueling my batteries. And so I know that a lot of folks that are in this business get into it for those same reasons. So I'm going to start my presentation now, and give you guys a little more glimpse into what it is that we're talking about tonight. Here we go, share screen. Nice. Yeah, so going to talk broadly about the larger landscape of biocomposites, mycelium-based biocomposites. As an artist, like I mentioned, I feel like it's really important for us to start to think about how we're going to move from the old ways that we used to do things into the new ways that we can be doing things the current status quo is it's just unsustainable. We're not going to be able to keep producing plastic goods, timber products, all of these things for you know, indefinitely. We know that at a certain point, all of these resources are going to be dwindling down to the point where this planet is just unsustainable. So we have to start thinking differently. And the reason why I titled this talk "The Landscape," a lot of us that are on the frontier lands here of frontier, because there's so little that we know about how to use fungi in engineering and in design. There are mountains of literature about the health benefits, how, you know, dozens of cookbooks, hundreds of cookbooks on cooking, but building with mushrooms, building with fungi, specifically mycelial bonds as a matrix, that's just such a new frontier. So when we're poring over the information, you have to start to retranslate all of the knowledge, the knowledge that we know, into a different framework, a different mindset. And so that's both exhilarating and it's also mind-bogglingly terrifying at the same time, trying to start a company when really it's just this loose partnership with an organism who I'm trying to communicate with, but haven't quite perfected that communication yet. And that's kind of where we're at. Having said that, you know, there is a need for us to start thinking about why we need to do this. And I know that you guys are the choir. I don't need to spend too much time talking about the why, but just like with any good business, right before any meeting, you want to restate your mission and vision statement. And our mission and vision statement of why in the heck would we make composites out of mycelium is because, I don't know if you guys remember that movie, The Graduate, but there's a scene in there when he's at that party, Dustin Hoffman, and he's this a friend of the family pulls him aside and asks him what he was going to do with his life. And the friend of the family told him, "I have one word for you: plastics. Plastics is the future." Now, that movie came out in the, you know, the late 60s, and you know, here we are dealing with what that future of plastics is. It's not a good one. It's actually quite grim, and for a lot of people, it can be a little overwhelming. As most of you know, since World War II, that's really kind of the main advent of plastics. And what's interesting is that there are some parallels between what happened then and what is happening now with biocomposites. During World War II, when there was a scarcity of materials, plastics got this enormous boost because of that. The plastics industry was just a very tiny nascent industry. They were really busy in their labs trying to figure out all the terrible chemicals that we're going to start pumping into our rivers and oceans, and all the terrible gases that we're going to pump into the air. And so they got this big boost because of the fact that there was a shortage of metals and wood products and the things that were going to the war efforts. As we know, that the problem with all that is that the promise of what was going to happen later, ways to clean it, ways to recycle it, all those sort of kind of got kicked down the road. These things don't degrade. We can even talk about ecoplastics, and ecoplastics are, in my mind, a cuss word. It's a really terrible thing. I really wish that the plastics industry would stop using that, because most of the times what they're talking about when they talk about biodegradable plastics is that they are just less harmful. It's not that they're not harmful, it's just that they're better than bad. And I'm tired of that. We have to start thinking about that better than bad is not good. We have to move past the thinking that better than bad is an okay way to design. Another thing that is a sad fact is that recycling is a misleading proposition. When you fill up your recycle bin, a lot of that doesn't make it into any other products. In fact, a lot of it just gets pushed to another couple facilities before it just gets put into a landfill. Yeah, there was a study that was done in Berkeley just recently, and they found that 45% of the volume that they collect in garbage was plastic, and it only accounted for 6% of the weight of that garbage. That's really mind-boggling when you think of that. Almost half of the volume only accounted for a very small amount, but it's going to be with us for hundreds of years because it's put into these situations where it's just not going to break down. It's not going to be in that ideal condition. So that chasing symbol that we see, that recycling triangle, it's rubbish. We need to replace that with some other new way of thinking. We used to, in the 80s and 90s, we would use all the plastics we wanted to. We'd throw them in the bins. It would go on ships to China, and then they would remake it into stuff and send it back to us. Those days are gone. China stopped taking our plastic waste a number of years ago, and it's estimated that by 2030, there's going to be 100 million tons of plastic waste that will have no place to go from the United States, and that's quite sad. A lot of the mycelium composites replace plastic and foam products, and then there are a few that also replace timber products. My own product, which I'll talk about later on, is one of those, and I am very driven to counter the effects of deforestation and forest degradation. The whole notion of extraction and manufacturing and transporting, just, you know, kind of like just churning and burning until there is no more, and then moving that to another place where we can continue to pillage the forest, the lungs of the earth. That's just such a mind-bogglingly terrible prospect for me. It was something that kept me up as a kid. It made me have very frequent existential crises as a kid, thinking about the Amazon rainforest disappearing, and really led me to what I do today, and why the kind of designer that I am is because that kind of stuff gives me the heebie-jeebies. The main reason being that deforestation and forest degradation accounts for 15% of climate change pollution worldwide. And there's that exponential effect that as the forests degrade, it's just this slippery slope. It gets worse and worse. And, you know, I'm not a negative person. In fact, I'm an eternal optimist, but I think it's important to be also discerning. And so when we talk about selective logging practices, which is what the timber industry wants us to buy as, you know, the better alternative, the better than bad alternative, selective logging has been shown in studies that one tree that is selectively logged will affect negatively the 10 or 20 trees surrounding that. So there's this incredibly terrible effect that happens, a 10x negative effect that happens with selective logging, and that's quite terrible. And really what we need to start looking for are one-to-one replacements for this. It really is one of those things that it feels insurmountable. It feels like we're never going to get there from here. But then I have to keep reminding myself that everything is temporary, and we just have to start somewhere. We have to start changing the way we think, and that's kind of everybody's responsibility. We have to start changing the way we design things. That's folks like my responsibility. And then back on that partnership between, you know, who makes things and who uses things, we need to change the way we consume and the way we build things. And if we start taking these issues on one at a time, like I'm doing my little bit, you know, Ecovative's doing theirs, MycoWorks is doing theirs. If we each start tackling these one at a time, then I think we're going to end up in a situation where we're gonna find ourselves able to navigate this. And it reminds me of a murmuration of starlings, one of the most beautiful things in nature that I love to watch. And there's a lot of really wonderful science behind this. And a murmuration of starlings depends on some three key concepts. One is that those birds each bird is worried about the 6 or 7 birds around them, which is a beautiful metaphor for our need to change to a circular economy, these regional regenerative economies. So they're only worried about the 7 birds around them, and they need to keep some separation from them. So that's the first concept. We do need to start to think about these things differently, and it's going to take a lot of people. I've never grown a single mushroom in my life. I've made a lot of mycelium, but I've never grown a mushroom. I'd love to someday focus on that, but right now I'm focused on building materials with it. But if everybody started doing little bits and just playing with not just mycelium, but other types of bacterial leathers is another fun thing. There's so many things that you and I, citizens, can just start doing. Most innovation happens from people just tinkering in their garage. That's exactly what happened here. The next concept that murmurations count on is alignment. And what's wonderful about all the companies that are working on this, we all do have this aligned vision of furthering the knowledge that mycelium fungi in general have the ability to do a lot of healing for the earth. And when we align behind that concept, I know that some really cool things are happening. And that's where the third concept of a murmuration of starlings is that they become one cohesive whole, and they move forward together, they move around together, they can twist and turn, they can change directions together. And I think as humans, we need to start thinking in terms of that. How can we think differently? How can we design differently? And that starts from the very beginning. My company was formed in 2018. And from the very beginning, I've thought about designing out waste, including in my process. Since last June, my company has only produced not even a full dumpster full of garbage. I reuse everything in my process, and I'm a prototyper, which is inherently wasteful. But I try to keep all of that garbage down to a minimum. I only throw it away when it is absolutely spoiled and does not have another use. So in nearly a year of operation down here in my shop in San Diego, I haven't even produced a dumpster full of garbage yet. So that's the kind of thinking that I know is catching fire. I'm one of many pioneers that are out there on the frontiers trying to think in these same ways. What's neat about working with mycelium is that it's, you know, when I talk to people about it, you have to remind them, and as you guys all know, that the fruiting body is such a small part of it. When it comes down to it, it's hard for us, you and me, without microscopes and things to distinguish between one fluffy white mycelium and the next. But there are some very specific species that are commonly used in the biocomposite world. The main one that is used in just about all of the major applications is Pleurotus austriatus. And the other main one that is commercially available right now in a product is the reishi mushroom. And we'll go over these in detail later. But yeah, there are so many other places that we could be exploring. And that's the other really neat thing that's on the frontier here. I'd like to just talk a little bit about what is a composite material. It's one of those things that I've marveled at. There are lots of composite materials that we know of that we've been using for thousands of years, actually. Mud brick is a composite material. It's mud and straw packed together. A composite material is just two or more materials that have vastly different properties that when they're put together have vastly different properties than each one separately. They can't dissolve into each other or blend. That's a mixture. That's a different type of material. But a composite material is going to be something that the finished part is greater than the sum of its whole there. When we talk specifically about mycelium composites, there are two main components to a composite. You have a matrix, and in our case, mycelium is the matrix. The self-replicating nature of mycelium is just so wonderful. I can take one bag of substrate, inoculated substrate, a kilo of that, and I can end up with 7 kilos in about 4 or 5 days just by spreading them into more substrate. So from a manufacturing standpoint, that is a really exciting proposition, that one of the main components is not some terrible adhesive, but just this wonderful self-replicating organism that can do very wonderful things. The other component of a composite material, any composite material, is that there's some kind of structural material. So in carbon fiber, for instance, a very commonly known composite material, you have that woven fabric, and then it's covered with resin, and then that resin hardens. Now, both of those materials are quite terrible for the planet, and the end of life cycle for those are just terrible, terrible things. So when we're talking about what kind of one-to-one replacements we have here, when you're talking about mycelium, a self-replicating organism, and then hemp hurd is the structure that most of the available rigid or foam-like applications use. Hemp hurd is can be a regenerative crop. And actually, just a little side note on that, what's important, I think, going forward when we're talking about composite materials, biocomposite materials, is that we just don't have what are called regrettable substitutions, where we're not replacing plastic with some composite material. Say hemp hurd becomes this really terrible thing that starts, because it's lucrative to build for foam or to grow for foam packaging, they start cutting down Amazon rainforest to grow more hemp. Well, that's kind of wholly missing the point. What we want to make sure we're doing is that we're building regenerative supply chains all while we're doing this. Yeah, so the need to start thinking in like these 10x effects. So we had the 10x effect of the deleterious effects of the other materials. When we talk about if we can grow these things regeneratively, that is the hemp hurd that's used. There are other useful substrata too as well. Any kind of agricultural waste product that has about a 20% lignin fiber content becomes a viable substrate for Mycelium composites. And then also the makeup of those. So what's useful about the hemp hurd, as you can see, there's those elongated particles there, those discrete particles. From an engineering standpoint, when the mycelium connect those together, it really creates a nice, strong, rigid material. If you've ever used oriented strand board before, it's a lot along the same lines of that. Actually, it's a kind of a macro version of what concrete is actually. Concrete being a mixture of cement and sand, the sand being the structure in that situation, and the cement being the matrix. The hemp hurd acts as the sand in that situation. So that the fact that it has those elongated fibers actually creates these really wonderful qualities there. What's really exciting is that we need to start thinking about one-to-one replacements for everything, and this is one core technology that could be used in several different applications. There's a term, fungal ecology, which a lot of you are probably aware of. And what that refers to are what are the environmental factors that contribute to the growth of the fungi that we're talking about. And so in the biocomposite worlds, the mycelium biocomposite worlds, like I mentioned, the main organism that's being used right now commercially is Pleurotus. And that, depending on what kind of environmental conditions you give it, will have foam-like qualities, it'll have rubber elastic-y type qualities, leather-like qualities, or rigid structural qualities, all just by tweaking the gas mixture by a few percentage points this way, with oxygen and carbon dioxide are the two main gases that affect the growth. Humidity levels, temperature, small gradients along those movements along those gradients, I should say, can create profound effects on the finished product. And that, to me, is part of the enormous wonder of mycelial-based composites, is that it's like this be anything type of, you just got to be curious, start messing around with it, and then eventually we're going to figure out lots of wonderful ways to use this. And I firmly believe that the concept of one-to-one replacements is something we designers and engineers need to start grasping really, really, really strongly right now. There are those companies that are moving forward, but we need to start, like I said, aligning our vision a little better, being more cohesive. It's going to get better when it starts to move more into the university space so that we can maximize that effect, the delta that we have from where we were to where we want to be. And what's been happening so far is that there are folks that have identified some kind of pain point, plastics being one of them, or foam plastics being one of them, and then testing whether or not it was a fluke that you made something that could replace that, and then test it again. Is the approach going to be novel enough to make a difference? Test it some more, make sure you can consistently create this material. And then you have to prove it. It's hard to prove, but you have to do that hard work. You have to be consistent. I do consider myself an artist first and a designer, but science has always fascinated me, and I feel like more akin to the Renaissance thinking of, you know, all art and science are interrelated with each other. And I firmly believe that we need to really embrace that as designers moving forward. We need to make sure that when we're proving this out also, that a material just used for a material's sake is bad design. A material that's used appropriately because it has some value add, that's really good design. And it just so happens that mycelium provides us with several really key value adds. Fire retardants in textiles, fire retardants in building materials, and in the components that make up our furniture. They are terribly toxic just to make, and they are incredibly toxic when they burn. They're very dangerous to firefighters, and they actually contribute to fire acceleration at a certain point. And it's just ridiculous that they're still used. What's wonderful is that mycelium has the ability to actually coat the discrete particles in a composite, and it gives it natural fire resistance. In fact, this is, I don't know, can people see me right now? I don't know if it's just my screen, and maybe if you could see, but that is a burn mark right there. I held a lighter to this, I don't know, for 3 or 4 minutes one day. Somebody was asking me how fire resistant is it, and it just doesn't catch on fire because that's the qualities. It takes a lot of heat to get up there. So, you know, does it appropriately add some value to a prospect? What's also wonderful is that mycelium have a natural hydrophobic quality. When they get stressed, in certain applications that we can dream up in the future, they could be self-healing as well. That's kind of a neat future type of thing. Also, is it appropriate when it wears, and is it appropriate at the end of life? At the end of its useful life cycle, what's going to be the outcome of mycelium-based composites? Well, you chuck it in your backyard compost bin and it'll break down into soil. That's the most wonderful thing. It's almost one of those, it seems too good to be true, but it's not. As long as there's no adhesives painted on it or no paint painted on it, and it's easy to get back down to that mycelium composite, something that looks a lot like that composite you see there on the screen. That is a backyard compostable item. It's important to differentiate between something that is biodegradable and something that's backyard compostable, because backyard compostable is an enormous claim. Something that's biodegradable in a perfect scenario is going to be able to break down. Something that is backyard compostable means you just chuck it in the back and you forget about it, and it is going to break down. That's what's wonderful about these things. Another thing that's important to prove is that, is it appropriate for that application? And when we talk about the specific things that are on the landscape, I'll talk about their specificity and the applications there. And then I also think, and I already touched on this, is it ethical to produce it? Can we do it regeneratively? And can we do it where the cost economically, it's not going to be prohibitive, especially for poor communities that are often left out of types of materials that are sustainable, regenerative type materials are usually out of the reach of most folks out there. And that I think also needs to change. regenerative design needs to be our practice, not a kind of an aspiration, but it needs to be standard practice. The other difficulty for bringing these types of things to market is that once you've done all of that testing and you've got a prototype, then you've got to test everything and do it again, and you've got to do it bigger each time and more of them each time, and that takes money, and it takes what a lot of folks are finding right now is it takes a multidisciplinary approach. It's not just designers. It can't be just structural engineers. It's actually going to have to require the interaction with folks from academia from several aspects. Economists who do LCA analyses on these, mycologists who do 15 years of research on obscure species that could be used to produce certain qualities of composites. That multidisciplinary approach is really important. The other thing that's important about raising money, because money makes the world go round right now, is to develop regenerative supply chains. And that can't be understated, actually, or overstated, I should say, that the need for regenerative supply chains. And what I mean by that is that there are no things coming further than 250 miles away, ideally. I mean, that's gonna, there are some definitely exceptions to that. But ideally, things would come from within 100-mile, 200-mile radius of the actual production of that material. And that at the end, when there is a material, that they are distributed to maybe a 500 to 700-mile radius, maybe a little larger region, depending on what the type of material is. But these types of circular models need to be built into the very beginning of the designing of these composites, because we don't want to run into the same situation that they did with plastics, where they just felt, they'll figure it out later. Same thing with nuclear energy. Oh, they'll figure it out later. We haven't figured it out yet. It's just, it's not, we can't kick that can down the road anymore. And what's wonderful is that the ability to raise awareness is kind of easy right now. The documentaries like Mycelium, Fantastic Fungi, books like Mycelium Running have influenced a lot of people. And it's great that this is kind of becoming part of the common parlance, and being able to say regenerative design and have my 70-year-old dad know what I'm talking about is great. You know, we can have, he as a businessman, he can start to see the economic value in regenerative design. And now we can start to have a different conversation there, and it's starting to take hold. So it's really interesting and very exciting to be a part of this movement right now. A little bit about the properties that make mycelium so special for composite materials. I mentioned about the fire properties. It's hydrophobic, naturally hydrophobic. What I've found in my research is that when it gets wet, waterlogged, and then it dries, it actually becomes stronger than it was before. So it keeps, if it does get waterlogged, it doesn't get damaged, it actually gets stronger. That's a really interesting property. The other thing, and some of you might know this, but some of you might not, is that mycelium, the cell wall of mycelium is chitin, and that's the same substance that's found in shells, in exoskeletons of insects. Chitin is one of the, chitin is the most abundant material on the face of the planet. And it's also very regenerative. It's easy to break down, and it's also very strong. When it's in use, it's very strong, and when it needs to be broken down, it's easy to break down. In fact, one of the better substrate additives that you can add to any mycelium composite is other old spent mycelium. So talk about the ability to recycle the old in with the new. It really doesn't matter what condition it is, because of the bioremediation process that the mycelium also does. Michelle had mentioned that you can actually feed it dirty stuff, and it will break that plastic, resin, whatever it is you're breaking up in there. It'll actually break those down into safe, usable components that are safe later on at the end of that new product's life, as long as you give it enough time to ferment on that. I mentioned the two candidate species that we know of right now, and those are P. ostreatus and reishi. But there are a number that are obvious candidates that people are looking at right now. I think it's important to talk about the research. There are several really great researchers that are doing really great thesis work on this. There's a whole generation of scientists, materials engineers that are doing cross-disciplinary research with mycologists in order to find really great solutions. A lot of the research that you find right now, which is very necessary, is research into looking at what's already been done, and that's very necessary. What's exciting is that there are researchers like Elise Elsacker. She's in Belgium. She's the third one on the list there. In fact, I can't remember the exact day, but if you send me an email to that email address right there, she's actually doing the defense of her PhD work in a few days. It's in about a week or so, week and a half. And you can watch it live. It's going to be pretty cool, but her whole PhD research was on mycelium-based composites. So that should be a very interesting talk. A lot of the researchers that I have listed here, these are some folks that have written some really great papers. I'm really happy to share my bibliography with folks. Just like I mentioned, just send me an email and I happily share that. Also on my website as well, you can see some of these. And as I get my blog up and going, I'll be posting a lot of the research. I think it's really important that we do have good proof for all of these things. Here, 1 second. Okay. So now I'm just going to go into talking about the things that we have there out in the wild right now. These are things that are here, right here today, and it's really exciting. For each one, I'm going to talk about what's the incumbent technology that it's replacing, what's the level of replacement that it's achieved, and what's the potential for scaling up to the ability to 100% replace the incumbent. The next thing that for each of these is I'll talk about what's the level of success to date. That's important. If it's not commercially viable and it's just an idea that's only usable in very small amounts, then we're not going to be able to tackle the problems, the bigger problems that we're facing of deforestation. A lot of the great replacement items that we're going to be looking at, and this is the way that I'm structuring going through these is actually a timeline. It goes through the very first innovations through to what we have available today. The first on that being foam packaging. And it's a great place to start with the progenitors of the whole idea of making composite materials. You guys have already had these folks come and talk. It was a project that they had thought up at a design symposium at the school that they were graduates at. And this is the outcome of that is this foam packaging replacement. Talk about a wonderful one-for-one replacement. That's a really wonderful one. So Ecovative Designs, a mycocomposite material, was, like I mentioned, it was developed initially in 2006. It didn't find its way into the marketplace until 2011. So it took them 5 years to get from this great idea to something that they can grow and supply at a commercial scale. But they were very inspirational to the work that I'm doing for sure, and very helpful from a scientific perspective. They were a very great sounding board for me. So I know that the work that they toiled through for 5 years has created this accelerant throughout the rest of the folks that are looking at these materials, because they've taken so many lumps in the very beginning. But the elegance with which they've achieved it is great. It is a true one-to-one replacement for foam packaging. If you can see on the screen on my picture here, this is grown with Ecovative's formula and their process here. It's soft when it has the fungal layer that you can see, that white fungal layer there. It has a little bit of give. It's a true replacement for EPS foam packaging and other types of expanded foam. What's great is that unlike EPS, which can be recycled actually, but in very, 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 very minute amounts, because of the fact that it has to be extremely clean, no paint, no adhesives on it whatsoever. So it is a true one-to-one replacement that is backyard compostable, and that's really exciting. So when you get that box from Amazon in the future, when they can figure that out, how to make it at that level, and that's the limiting factor right now, is that there's a lot of handmade qualities to the process, and there's a lot of automation needed to get it up to that scale where they could supply, for instance, Amazon. But what's really neat about this is that they have been extremely successful to date. They have raised $90 million, and that is an exceptional amount of money. In fact, 60 million of that was just announced just a few days ago. They've got what's called their Series D funding, and they're now looking at building these foundries, these mycelium foundries all over the world, in hopes of building these small, short-cycled foam packaging replacement factories. And it's really exciting. They have a lot of major market acceptance. From the very beginning, Dell started shipping computers using their mycelium packaging. They signed a big deal with the company that gives us the air field packaging, Sealed Air Corp. They signed a licensing deal with them. IKEA, Steelcase, Gunlock, several furniture design companies are using these as packaging for shipping. It's a really, really incredible material. It's the start of it all. And from this, they have been able to spin off a few other different products, actually. The next one that they've come up with, staying with Ecovative, is a product that they call Microboard. And they would grow the mycelium into these sheets. They'll put it in these large presses, a lot like they make, how they make plywood, as it's commonly known. Or oriented strand board. You know, they put in those same types of presses. In some cases, some clients have wanted them to infuse resins in it, but in their ideal formulation, they just use the heat to bind together the different layers. And they take these 1-inch thick layers, about 14 of them, and they press them down with a lot of heat and pressure, and it makes these 1-inch boards that are incredibly strong. Not a structural material, but incredibly strong. Gunlock is a office furniture company, and they are using Microboard in a lot of their chair designs. Those two chairs that you see there, those white chairs, those shells are made from mycelium. So if you're going to put some furniture in your office and you're looking for some sharp furniture that's very sustainable, buy some Gunlock furniture with some mycelium. Another product that they made were these hand planes. This is a company that's down here in, I think they're in San Clemente, actually, just a little north of here. And those are body surfing hand planes that are made with mycelium. It was the first sports equipment made with it. Microboard is interesting. It was, they had kind of come into the technology around 2013. They didn't put it into the marketplace until 2016. And they consider it a one-for-one replacement for oriented strand board. I would agree. I think it is a true one-to-one replacement. I thought about it too late. I do have some Microboard here. I would have put it up here on the screen for you to see and kind of thump it and let you hear the qualities of it. But it feels strong. It's a very strong material. But they do not claim that it's structurally sound, and the science bears that out as well. It's really unknown what its potential to be a true replacement for oriented strand board. I think that they've kind of moved away from focusing on this particular product in favor of some other products. The next one that we're going to go over. is the next one there. So there is some acceptance in the marketplace, but their real focus currently are on these pure mycelium products. Now, this is not in essence of mycelium biocomposite, because if we go back to our definition of what a composite material is, that would be 2 or more materials. In this situation, this is just pure mycelium. Now, the way that it's grown does involve some other materials that then can be recycled into a next generation, but the end product is actually pure mycelium, and it is incredible to touch. As you can see there, it's twisted in a knot there. It's very durable. It's found its way into clothing and shoes. It's used as beauty sponges, things when you go to the pedicurists, they're used to put the little foamy things in between your toes. So there's a lot of really great uses for it. Pure mycelium is something that does have a really true one-to-one replacement for those foam products, like those sponges that are used for makeup that are only used a couple times and then tossed. Well, it's great. Now you can compost them. It really is unknown, the potential for this right now, only because figuring out how to scale up growing this at a commercial scale is what's the tough thing here. There's been some acceptance, though. There are some major companies that are looking at this, Lush being one of them, actually. The next item we're looking at is these are acoustic wall panels, which typically, it was mentioned that I'm an interior architect, and we coat walls with things to mitigate sound, reverberation, and there are some heat qualities to that too, but mostly for acoustic mitigation. And those materials are commonly just terrible foams. And so the fact that there is this one-to-one replacement grown with mycelium is really exciting. Mogu has been doing this since 2016. They are licensing their technology from Ecovative. I've tested out all kinds of different acoustic wall panels, and it is a definite true one-to-one replacement. And they have gotten a lot of success in the marketplace. They've been able to raise some money. They're a European-based company, so it's difficult for them to break into the US market, but there is some good market acceptance for it. They're considered the standard for sure. The next really, really exciting one, and you may have followed this, and if you haven't, I strongly encourage you to go check out MicroWorks' website, and then their companion website, Made with Reishi. Oh my gosh, it's just so beautiful. I haven't touched or felt this. The amount of it is in very short supply. That bag that you see there is the first product that was made with it. Hermes was the company, I think I'm saying that right. Hermes, they're the luxury brand that was the first lucky folks to get a huge quantity of it. But reishi is a fantastic composite material that when they test it side by side with animal leathers, it is a one-to-one, true one-to-one replacement. It can tan like animal leather. In fact, one up actually. It tans better than animal leather because the toxic processes that are used on leather right now are not necessary for mushroom-based leather. So that's a really exciting thing. As independently tested, it took them several years to get this to market. It took them about 5 years to really get up to the level where they can create this commercially. And it is an absolute one-to-one replacement according to independent lab testing. And I think that of all of the composite materials that we talked about so far, this one is the one that is very highly likely to actually be a 100% replacement for animal leather if the marketplace would accept it. And the reason being that their process for growing it, they can grow this in sheets and by the acre within warehouses. Acres and acres of this stuff can be grown in ideal situations. So I think that it's going to be quite a successful material. To date, in this short lifetime that they've had as a company, they've been able to raise $62 million, which is a significant investment. What's going to probably help out is that they have really big names behind them, like Sophia Wang, Hermes, John Legend and Natalie Portman are both investors in their Series B funding. And so it's really exciting. And I think that MycoWorks and Phil Ross are going to be doing some really cool things here in the very near future. So there are some other things that are out there, and I see that we're a little over 8 here, so I am wrapping up here. I don't know if you guys saw the splash that happened a few months ago, but there was a guy in Northern Europe that came up with a way to create coffins, so you can have a funeral out in the forest, and they can put you in this mycelium coffin, and they have these specific species that are working with the ecosystem, the biome in the forest, that break down your body and make you into a part of the forest. When I die, that's exactly how I want to go. I'm really excited about that. He's a really neat, humble guy, and I love listening to him. His company grew super big overnight because he had a press release that was way bigger than he thought it was going to be. And so to date, he's trying to make a lot of hay with just a very little bit of time that he's been in there. Those lamps that you see there, that is another Ecovative made product. It's designed, the name of the designer escapes me, but another really neat use for mycelium is in these neat furniture design applications. One of the things that pulled me to mycelium in the first place was that as a designer, I was looking for a way to make a chair. I'm infatuated with chair design. And so I was looking for a way to make a chair out of mycelium and I started researching it. And you see a lot of mycelium chairs out there in the market, or I should say on the internet. There's a glaringly obvious thing missing from each of those pictures though. And that's there's nobody ever sitting in those chairs. And there's a reason why, is because the previous formulations aren't strong enough to be load bearing. And so if they are strong enough to be load bearing, it's because they just grew mycelium around a chair. It's not actually a mycelium chair. So that was a driving force for me. I wanted to be the first designer to make a chair that was purely made from a mycelium based composite, something that is still backyard compostable, that didn't use any adhesives, that used the power of mycelium to adhese itself together. Actually, if you want to look at the screen there, this chair right here was one of my second things that I made here, but all of these components are glued together just with mycelium. It's quite incredible. And it really made me excited where on my second try, I was able to do something like that. It's kind of, I don't know, I'm not in charge here, the mycelium are in charge. I'm just along for the ride. But after making that proof of concept, I realized that what I was on to was actually a very different formulation than had been previously known. When you read the research that is available, they always describe mycelium as having foam-like qualities and or being made into the pure mycelium applications that are like textiles. That intrigued me because I was holding in my hand something that was not foam-like. It is much more akin to hardwood, somewhere between hardwood and carbon fiber. And I have sent these some samples, just like the one you see there on the screen. In fact, that one particular sample was sent to a really cool company that makes straw bale prefabricated wall panels. And they're based in Vermont. They're called New Frameworks. Wonderful company, employee-owned cooperative, fantastic people. I sent them this particular sample that you see there. They're very excited. Their structural engineer has been taking a look at this. I've sent it to Chris Magwood, is another architect builder up in Ontario, Canada. He's got a few samples as well. What it looks like right now, and we're still lacking the hard data on this yet, is that this is going to be able to be a one-for-one replacement for timber and building houses. And when I say it, actually, I get a little sick to my stomach because that is a very big disruption and it puts a big target on my back, of course. But what I've always maintained is that as a disruptive technology, there are real lives attached to the industries that you're disrupting. So my whole concept would be, I don't want to disrupt and just thumb my nose at the timber industry. I'd like to work and partner with them to see is there a way to retrain what they do and to focus on, instead of extracting from forests, let's keep the forest, let's manage the forest for what they're most useful for, and that's as carbon sinks. And let's instead grow building materials in warehouses with solar panels on the roof and using zero waste regenerative practices, so that we can build houses with things that at the end of their useful lifespan are still backyard compostable. That's the real exciting thing. My product is not something that is commercially available yet. In fact, I'm only able to make these on meter-long sections right now. But it is structural, anecdotally speaking. We'll be having some data later this summer, hopefully. But it's a really exciting leap forward. And one of the exciting applications of this, like I said, is to build housing. There was just $2.3 trillion put aside by the Biden administration to look into ways that the building industry can combat climate change. When I read the request for information for these initiatives, I just get really excited, because I think to myself, well, this is great, because this little thing that I've made here, these little things are cute, but these are insanely strong. The shortest one there in the back, the short brown one there, I actually rolled my car over that one a few times just to test to see how strong it is. As you can see, they're made as hollow structural sections there, and they're insanely strong. So I'm gonna wrap it up there, but just to wrap it up, I really do believe that we have to think in a multidisciplinary way. Bringing this into the university is essential. We need to think from the very beginning in regenerative ways. So as a materials designer, while I'm designing the application for that material, I'm already thinking about how is it going to exist at the end of its life. And when it's appropriate to use, then that's when it makes it there, and not a moment too soon. Just like Gandalf says, you know, the wizard shows up exactly when he intends to. Well, I feel like the mycelium show up in the marketplace exactly when they intend to. And we need to be honest about what these materials can do. And we also need to be honest about what they can't do. And that's kind of Materiality 101, is appropriate uses for the technology. And I think another thing that I think is important thinking forward is that these technologies aren't too big to fail. They're too impactful. They're too important to hoard. So the current mindset of using patents to strangle a technology, that is not interesting to me. I really think we need to start thinking in very different ways about how this kind of technology, self-replicating organisms, can actually save the world, but not if we have to pay exorbitant licensing fees in order to do that. So the way we get around that kind of greed, I think, is just by changing our thinking. It's going to take folks, when you see these products in the marketplace, be early adopters, knowing that there might be some pain points moving forward, but this is the frontier, and it's going to take us all to move forward and get through this. So if you see something out there, be an early adopter, buy some of this stuff, go to the websites, go to conferences. When COVID's over, come visit me at my shop. Let's talk about these things. Let's teach each other how to build this stuff, and let's move this stuff forward. So that's all I have. I totally forgot all about questions, Michelle. So I didn't even see if there are any, Michelle.
Oh, no, you're good.
Okay.
You're
I
good.
was so focused on the slides there, I didn't see any questions there. So.
No, you're good. Thank you. That was a lot of really, really good information, not just on your products, but in general, how the world is going, and kind of a little bit of like what we can do in it. One of the questions we did have, and then I have a few more for you, as well as I invite everybody right now to put your questions in the chat, so Joshua has a chance to answer them. One of the questions was, can you drive nails into the structural pieces that you have made?
Yeah, that's a very good question. Yes, you can. and you can also screw directly into them without drilling any pilot holes. It holds a screw very well. Those data are forthcoming, though, about the actual numbers, the actual force that can be applied to those. But yes, they hold nails, screws very well. Yeah.
Awesome. Yeah, that's one of the most important things, right? Because it's like, you know,
Right.
you're trying to get into the big scales in order to make buildings eventually and stuff like that.
Right.
Cool. Again, I encourage people to put your answers in the chat. Otherwise, I have a few for you. One is because you were talking about the Mycocomposites, and I think you're right. Like Dell has already done it, and IKEA has done it. But what would it take for Amazon to start using it? So I mean, 'cause it's insane how much products they're outputting. So what do you think?
It would take Amazon because they already have these enormous warehouses where everything is at. And so if they added in these mycelium foundries and they were growing it in-house, because they have the scale with the money that would be required to build the bioreactors those big and to hire the bodies, I think it would just require them to say, hey, we're just going to grow it ourselves. And then Ecovative could show them how to do it, license it, and boy, they would be, yeah, if you made 1/3 of 1 cent on each one of those foam parts that were made, you'd be doing all right, and we could put that money to fixing deforestation. Yeah,
good.
Cleaning up the oceans.
And along with that, what is it going to be taken to take these into like second and third world countries so that they're able to use this instead of plastic?
Yeah, that's a good question. And a lot of the thinking behind this, I know for sure that Ecovative's thinking for the foam packaging replacement, and what I'm thinking for my building material, is that it's not going to be grown in Ohio and shipped all over the world. It's not going to be grown one place and shipped all over the world. The idea is to actually, if it's going to be made in a region, then you need to find the appropriate substrate that's useful there. And is there a better candidate species that grows with less inputs that maybe you don't need to add humidity to or add any heat to? These can all drive down the cost. So when we're talking about building these or making this stuff, actually more appropriately, growing this stuff in poorer countries, it's eliminating all of the extra technology that's needed. Big heavy presses, that's not going to really work. Easily built molds, that's going to work great. Processes that just require a little bit of water, a little bit of non-food grade nutrients to put in there, yeah, that could be done all over the world. The main component, the structural component in these composites should be agricultural waste products. So these are things that are available all around the world. It's just finding that appropriate agricultural waste product that works there. And I don't see this being a barrier to that at all.
No, I just see this as a growing educational piece. You know,
for sure. Yeah.
And what part of the world, what they need.
Yeah. And I think that it, like I said in the slides, is that it really takes thinking about it from the very beginning. We're going to build this regionally. So there has to be several centers throughout Africa. There has to be several throughout Southeast Asia. And it's going to take that kind of thinking from the very beginning in order for it to penetrate through to the poorer countries.
Awesome. We do have a few more questions, and one was if you can drive nails into the structural pieces, which you had said yes. And if you could attach structural pieces together by growing mycelium at the joints.
That's a good question. That's yet to be tested. We will be testing that later this year. There's a great university-based lab called the Living Materials Laboratory at University of Colorado, Boulder. And Will Shrubar is the chief investigator there. And he's going to be doing a lot of testing. We've developed a relationship. So for the next 2 or 3 years, be looking for a lot of research coming out on those very questions there. Yeah. I saw the question also about the testing of the flammability, and there are actually research papers that if later all of these questions that have research associated to, if there's a way to save these questions, Michelle, I can give you guys a bibliography and kind of footnote it for you guys to point you in the right direction there.
Yeah.
But there are some great, just off the top of my head, the researcher that has a lot of these data his name is Mitchell Jones. And if you've never used Google Scholar before, go on to Google Scholar, type in Mitchell Jones, and you'll see a lot of great research on there. You can at least read the abstracts there.
Awesome. Yeah, and we can definitely, if you send it to us, I'll make sure that it gets to our members. Another question was, how does the building material stay strong enough to make structures still be able to break down daily for compost? Is it treated to keep integrity? And
it's nothing that we do. So this is a part, this is a non-structural part that I grow. These are cute little flower pots that I grow with the excess material that I have. And actually, Sarah and I are gonna do some fun projects in the future where we're gonna be dyeing these with mushroom-based dyes, actually. So that's gonna be fun. Maybe these will be available on the SD Myco website as a fundraiser or something. It'll be fun. But it has to do with the post-processing, actually the pre and post-processing of the way that the mycelium grow. And I'm always very careful to correct myself. I don't make this stuff, I grow it. It's grown material. And the fungal ecology that I use to make this material produces this really strong and rigid quality. Now, if you know anything about mycelium, you know that there are three main types of hyphae. There are the generative hyphae, that's the kind of the quick spreading ones. There's the structural hyphae that are give some real nice rigidity, usually found towards the base of the stipe. And then there's the binding hyphae that you see in more of the kind of the globby, leathery ones. But there are certain species that are trimitic, what are considered trimitic, and they have all three types. And but you're not going to get all three types expressed unless you have the right fungal ecology. And the way that I grow the materials, it better mimics natural environment for the organism. It's my hypothesis, at least. And it gives it what I can tell, allows it to grow all three types into one composite material, tuning it throughout the material. And so there are no adhesives that are used throughout the making of the material. So if at the end of its life, you were able to strip away if you use drywall or plaster or whatever, and it's inside of that building, just like when you break down a wall in your house, when you're remodeling, you expose those studs. So imagine this being the size of a stud. You can now pull that out and you can still compost this because you haven't added anything to it. You'd have to pull out the nails maybe later with a magnet or something. But yeah, it's through the wonder of mycelium. It's not a process we fully understand yet. Stay tuned and keep reading the research. That's why I think building some relationships with the mycology departments with the local universities is a really important thing for me, because I would like for researchers in mycology departments to start focusing on what are the species, what are the qualities that we can get just by tweaking the fungal ecology.
Yeah, absolutely. One thing too, would you be able to tell us about your personal work, Oakham Works, where that name comes from and what that's all about?
Sure. As a designer, I am always keen on going to the most simple way of tackling a problem. And you may have heard of the term Occam's razor. And so Occam's razor says that the simplest way to explain a set of data that you receive from testing a hypothesis is probably the most correct answer. And it helps us to not, like I said, we want to be sure we know what it is and what it isn't. So that helps us to say, well, it doesn't do this. And so for years, it seemed like foam-like things were all we could make. So that's where all the research and effort went to. Now we're saying it could do things structural. So it's that Occam comes from Occam's razor. And Occam Works Labs without the O. That just looks fancy. And I spelled Occam differently with the K. That's just because I'm a fancy design firm. So that's, you know.
Yeah, you got to go along with that. And is there any way that we can support your company currently?
Yeah, great. Follow me on Instagram. That'd be a good way to stay up on it. I have my website, occamworks.co. That's hard to spell and remember. So structuralmycelium.co as well is the way to get there. Occam Works Labs is my Instagram, actually. The Occam Works one is my older one, and I'm just trying to figure out how to get rid of it. I'm terrible at it. So without the O, though. There it is. Oh, shoot. Here, let me type it in there.
Yeah. I'm like, too many. I'm sorry, people.
Labs.
Sorry,
here we
friends.
go. This is the one. That's the one right there. Occam Works Labs. That's on Instagram. And if you just go to my website at structuralmycelium.co, then you'll be able to get in, and you can find the link to my Instagrams at the bottom of the page there. So, yeah. One thing you could also help is if you know of any materials engineers or mycologists in the area looking for work. I will be hiring very soon. Also, if there's any digital fabricators out there that you know of that are hotshots and know a lot about robotic digital fabrication, I'm looking for somebody that can do that as well. Also, people that just are interested in design and that would potentially, I'm going to be hiring 2 design assistants as well too. So. Yeah, a lot of hiring in the next few weeks here. And so that's another way you could help me out, is spreading the word on that.
Awesome. We definitely will. And yeah, for all you mushroom lovers, if you know of anybody that he just spoke about, please send them his way. And I had 2 more things. Just what I wanted to reiterate with one thing that you said that I thought was great was that regrettable substitutions versus regenerative supply chain. So I just wanted to reiterate that the regenerable substitution that we have seen, like plastic and other things, come up as a way to substitute, but it's not good for the long run. And at this point in time and in the world, we kind of need things that are going to be more sustainable, because we're kind of breaking down pretty quickly. So in that sense, I think those were 2 key aspects that I really appreciate that you mentioned. And one more thing is, because now, you know, are there any publicly traded micromaterial companies in which you would recommend both researching and investing in?
Yeah, I would say at this point, EcoVeda is probably the closest, and maybe MycoWorks is probably the one right behind them, closest to doing something like that. But instead of those companies, which are privately held still, investing in the firms that those venture capital firms that have these funds that invest in these kinds of businesses to the tune of $60 million. Those folks, if you have a 401k, put your money into those kinds of companies. I don't have that information off the top of my head, but I'm happy to scare some of that up. They are data that I have available. It's just I don't have them at my fingertips right now. So if anybody has a question about that, email me and I could send you some info.
Yeah, and I already put your email in the recording.
Okay, great. All right.
And then the last thing is, what would you recommend to us as individuals of like what we can do within ourselves to be able to help promote and just clean up the environment?
I think we need to change our thinking and our way of talking. We need to move past sustainability, and because we can't sustain what we're doing, like you just said. We need to now start saying things like regenerative, and we need to make that a thing and just keep saying it. And when you say sustainable, say, what I mean is regenerative. And when then somebody says, what do you mean by that? Then we can explain these things. And then it's a great opportunity to talk about how fungi are kind of the epitome of regenerative organisms. So yeah, it's a kind of a thing that way. Use less plastic. That's a big thing. Buy things local. That's a really big thing. Even if it costs more, buy things local. Go to the farmers markets. Let's stop shipping these things from China. If you had Easter and you had a bunch of those plastic eggs, stop it. Why? Let's not do that anymore. Let's make better choices as humans here, so that we can stick around for a lot longer.
I'm just putting that in the notes because there are some. Well, thank you so much, Joshua, for being a part of the San Diego Mycological Society.
Yeah,
we honored you.
I am a new member too. I just joined so earlier this year. So I'm a happy new member.
Awesome. Well, we're happy to have you for sure. And again, yeah, send me all, well, I'll send you, everybody, I'll send the information, so you can get a hold of Joshua and all his work that he's doing. But we really, really appreciate you, coming on this Monday, on the first Monday of every month, and sharing your time and your presence with us. We try to bring you some, exciting topics. A lot of it for us, a lot of it is education in order to be able to create this world a more regenerative place for all of us. So we really appreciate you being with us. Just so you know, our next monthly meeting is going to be May 3rd. At 7 p.m. Same with Doug Bjorn, will be discussing his book In Search of Mycotopia. And for those that don't know, we have our own YouTube channel, and all our Fungus Fair videos are on it. So if you haven't seen it, you can check individual sessions right then, or I would recommend you guys watch the whole thing, because we have quite a few of our vendors as part of it. And as least for, if you guys like truffles, we have 2 truffle vendors that you can get a really good discount on, as well as mushrooms. So we highly recommend you using that. Stay connected with us on Instagram, but if more importantly is go find some mushrooms out there and plug them into iNaturalist. Other methods as well, but we really want to, like, again, we're mostly dealing with education. We have started our own education fund, and we really hope to make a big difference in the world, both here in San Diego, knowing what's going on here, but as well as the world in general, because it's mycelium, you know, it's all of it underground. And we're really trying to form this tight-knit and expansive community. So again, we really appreciate you being a part of it. And again, Joshua, thank you so much for such a wonderful presentation. That will know a few other places that we can connect with you. And for everybody else, thank you so much. I hope you guys enjoy that. Feel free to reach out. Let us know anything else you want to know, and we'll see you for a few more speakers as well as classes. And thank you again. Take care.
High five.
High five. Thank you, Josh.